Okay, in this video, a very quick video, we're going to look at a complex circuit. So what we're going to do with a complex circuit like this, when we've got two power supplies. So we need to consider the loops in the circuit. Okay, and we need to do a little bit of simultaneous equations. Okay, so I've just popped some values into the circuit, and the first thing we need to do then is once we're looking at our circuit is establish our loops. So we've got our 14-volt battery here, positive. We just need to decide where the current is, so we can have a current going down through there, and we can call that I1, and we can then have a current here. We've got positive part of the battery there, so we'll just arbitrarily make current there I2. We don't necessarily worry too much about them. We just need to make a decision on the current flows. All it will mean is that when we go through the answers, work it all out, then if we get a minus reading, it just means that our current is flowing in the opposite direction to where we've drawn the arrow. That's all it means. So just take the positive and then just draw your arrow from there. Okay, so now we've done that, we need to just establish what's in each of the loops. Okay, so in the first loop we've got 14 volts, and then what's that equal to? Well, it's going through a 6 ohm resistor, so 6I1. Why? Because resistance times current equals voltage. Remember, so Kirchhoff's law, all the voltages should add up across the components. Then we're going round, following the loop round. So we've got a 3 ohm resistor, but that 3 ohm resistor has not only got I1 going through it, it's also got I2 going through it. So we can then say that effectively that voltage is going to be equal to 3 ohms multiplied by those two currents going through it, and that's that first loop. We do exactly the same thing for the second loop. So the second loop consists of 7 volts going through a 4 ohm resistor, so 4 ohms times I2 would give the voltage across that resistor. And then again it would be exactly the same thing. The voltage across that 3 ohm resistor is the combination of both I1 and I2. So therefore we've got our two loops. Now all we need to do is multiply everything out. So I've got 14 volts is equal to 6I1 plus 3I1 plus 3I2, and then we've got 7 volts is equal to 4I2 plus 3I1 plus 3I2. Okay, we'll just do a little bit of tidying up, so I'll just do all that in one go. Okay, so we've just done a little bit of tidying up there. Okay, I'll call this equation 1 and call this equation 2. Now I know your calculators will be able to do this, but I'm going to show you how to do it long-handed, and then I'll probably show you in another video how we can solve it on calculator. So going to do an elimination method. So looks like on this one, I think I'm going to multiply this one by 3. So my new equation, then multiplying this second one by 3. Okay, and then it means then I can then take equation 3 and subtract equation 1 from it. So if I do that, then I'm left with, so I've got 7 volts is equal to 18 I2, so I can then go 7 divided by 18 equals I2, which equals 388.9 milliamps. Okie dokie. So if I put that, if I putting I2 into equation number 1, sorry, that's I2, then I'm going to end up with 14 volts is equal to 9I1 plus 3 times by 388.9 milliamps. Okay, just need to grab my calculator now. Okay, so then just multiplying the 3 ohms by the 388 milliamps. So remember, resistance times current is going to give me a voltage. So then, so I can bring that across to the other side. So I'm going to get 14 minus my 1.1667 is equal to 9I1. Okay, and then a little bit more rearranging. So then divide that by 9, we're going to get I1. So I1 is equal to 1.37 amps. Okay, so that's what we've got there. Now there's probably only one thing that we probably left to do. If we look back at the original circuit, a question might say, what's the current flowing through this 3 ohm resistor? Well, we already established that the current flowing through that resistor is I1 plus I2. So if we wanted to know the current through the 3 ohm resistor, then we can just add the two currents together, I1 and I2. Okay, marvellous. Thank you very much. Hope you enjoyed the video.